Okay, 2b. So if you watch the video for 2a, why don't you go ahead and pause this one and see how far you can get. See if you can get h of x dealt with here a couple steps ahead of me. If you didn't watch the video for 2a and you're just jumping into 2b, you can just work along with it. Okay, so for 2b here, again, we want to switch f of x, or h of x here to y. I'm going to be a little lazy there. Switch x and y. So I'm going to have x equals 8y plus 2 over 2y plus 1. And now we want to solve for y. The first thing we want to do is clear that fraction. You can kind of, it's nice that these are on the same page and I have the work from the last problem. You can kind of, follow along. We're doing those same steps. Clear the fraction. Multiply through your x. And then we need our y terms on one side and our other terms on the other side. I think it's very easy to get caught up with like, oh, but I want my x's are together. We don't care really about our x's. We're solving for y. So I'm going to move my 1x over and move my 8y over. So on the left side of my equation, I'm going to rewrite this as 2xy minus 8y. On the right side of my equation, I'm going to rewrite that as a positive 2, so I'm going to write it as 2 minus 1x. Order doesn't matter as long as you have the correct signs going on there. So you could write it as negative 1x plus 2 if you don't like that order. And then here's the key step again. GCF out a y. Once you have your y terms on the same side, you got to take out that y. So I have two terms here that I can take a y out of. When I take a y out of my first term, I'm left with 2x. When I take a y out of the next term, I'm left with negative 8. Now that's not necessarily the greatest common factor. We could have taken out a 2 as well, but we want to get y all by itself, so that's really all I'm worried about separated at this point. And then to get y all by itself, we're going to divide both sides by 2x minus 8. That's h of x, so this is h to the negative 1 of x. Again, you don't need to worry about the domain and range on these, but just again to get it in your head, here 2x plus 1 cannot equal 0. So that means x cannot equal negative 1/2. So our domain restriction would be negative 1/2. Our domain would be negative infinity to negative 1/2 and negative 1/2 to infinity. That would be the domain of the original. It would be the range of the inverse. And then for our inverse, the domain would be x cannot equal, 2x minus 8 cannot equal 0. So add my 8, divide by 2, x cannot equal 4. So negative infinity to 4 and 4 to infinity. So that would be the range of our original and the domain of the inverse. All right, the problem like this on the test is one of the most missed every year, and it's because of this GCF situation. So please make sure that you practice these problems enough that you can factor that GCF out, that you don't get stuck kind of in the middle of the algebra there. Awesome, good job.